Hi everyone. As promised, I thought that I would go ahead and put up the sample problem so that you can see how to do a rational inequality for a polynomial. So if we look at an example, and let's say that we have f of x is equal to x squared minus 16 divided by x minus 1 squared, and we want that to be greater than 0. So the first thing that we want to do is factor the polynomial. The bottom is already factored, but the top isn't. So if we have x squared minus 16 over x minus 1 squared, that's equal to x plus 4 times x minus 4 all over x minus 1 squared. And we want to know when this is greater than 0. So we're really just looking at the sign. So if we start, we want to look for points where the sign could change. So we want to look at asymptotes and at roots. So the first thing that we're going to look at is the domain. So if I look here, the domain is limited because we can't have a denominator equal to 0. So we know that x minus 1 squared does not equal 0, which means that x minus 1 does not equal 0, and so x does not equal 1. So that's our domain limitation, and you'll notice that we can't reduce the polynomial rational expression, so that means that this is a vertical asymptote. So we have a vertical asymptote at x equal to 1. All right. So we have one spot. The next thing we want to look at is our roots, or our zeros. So here we look at the roots, or the zeros. And to find those, remember we want to find out when the numerator, either of those factors, is equal to 0. So our roots are going to be at x plus 4 equal to 0 and at x minus 4 equal to 0. So we'll have roots at x equal to negative 4 and x equals 4. Really not too hard. The next thing we do is kind of like what we've seen in some of the polynomial graphing, where we look at from negative 4, because that's the lowest point of interest. The next lowest point of interest is going to be 1. So we're going to look at around 1, and that's our vertical asymptote. The last one is going to be at 4. So we want to look from negative infinity to negative 4. We want to look from negative 4 to 1. We want to look from 1 to 4. And we want to look from 4 to infinity. And our sign isn't going to change. We're not going to cross that x-axis at any other time other than at one of those 3 points. So if we look at f of negative 5, f of negative 5, we will end up with 9 over 121, which is a positive value. So if we look in here, we're going to be positive, greater than 0. If I look at f of 0, I will come up with negative 16. So in this range, I'm going to have a negative number, and you can go ahead and plug these in yourselves. If I look at f of 2 for the range from 1 to 4, I have negative 12. So here it's a negative number. And finally, if I look at f of 5, that's equal to 9/10. 9/16, sorry. That's my bad writing that down. 9/16, but that is indeed positive. So what I'm seeing is that if I look in this range right here, and in this range right here, I'm positive, right? And since I just want greater than 0, I'm just looking for anything greater. So I'm not going to include those negative 4s. Those are roots. So x actually, or f of x actually equals 0 at those points. So what I'm going to have out of this is that f of x equal to x minus 4 times x plus 4 all over x minus 1 squared is greater than 0 when x is less than negative 4 and x is greater than 4. So that is our answer there, and that is how you do a inequality for a rational polynomial. Let me know if you have any questions. I hope this helps.